Hey y'all, this is OXDF, and today we're doing to Advent of Code 2023, Day 11, Cosmic Expansion. And basically we're going to get a grid like this, and it's going to have galaxies represented as the pound sign and dots representing empty space. And we need to find the shortest path using Manhattan distance, so just step over, step down, step over, step down, step over, step up, etc. And the only twist is that anytime there's an empty row like this, or an empty column, so like I think column 3 here is empty, um, then it actually represents two spaces instead of one. So if we do this one right here to this one right here, we're going to go 1 over 2, 3, because this column is empty, 4, 5, 6, 7, 8, 9, 10, 11. And that's it. That's really the whole twist. There might be some temptation, I think, to try to like update the grid by replacing all the columns. I think it's gonna be just as easy to just do this with some math. So I think we're gonna do that. But let's go ahead and take a look. I'm gonna use my Genday script here to pull a stub for myself as well as an input here. Let's go ahead also and paste in ex.text, paste that in, so we have that. Let's look at our input real quick. Definitely bigger. We have like 140 rows. We can do, there's got to be a better way to do this, but if I do cat input.text into tr minus d, like that, I still have a bunch of new lines in there, so tr minus d, get rid of the new lines, and now I can do word count minus c. There are 426 galaxies, so I think that pairwise, that means there's going to be 426 times 425 divided by 2, so roughly on the order of 425 squared divided by 2. Large, but not like, won't be a problem to compute, I don't think. All right, let's jump in. So the first thing we do, we're going to call this grid because there, and I'm going to just go ahead and save myself some trouble down the line, strip these new lines off. I think we can leave it as a grid and just work off of a list of strings. That'll be fine. So now the first thing we need to do is get a list of the galaxies. So we're going to do galaxies equals, it's going to be r comma c. We're going to be getting the row and column for, and this is, I'm really bad at doing doubly nested things. I think we do the row first. So we'll do r comma row in enumerate grid for c comma char in enumerate row. Sweet, no errors, that looks right. Okay, so right now we're literally just going to get every coordinate in our grid. What we really want to do is only get the ones if char is equal to, so that should give us a list of galaxies. We can test that real quick and run this Python day 11 example.txt, and let's pull up our example and take a look. So 0, 3, so rows 0, and this is, basically this is 0, 0 going this way, so row 0, 3, that looks right. 1, 7, row 1, 7, I guess probably right, I could count it out, but 2, 0 looks good. Nothing in row 3, right? Row 4, remember this is 1 index and this is 0 index, that's why I'm subtracting 1 here. Row 4 has got something in the 6, 5, 1. Okay, I think this is good. We got it. The next thing we need to do is get the empty rows. We're going to say r for r comma row in enumerate grid. And so right now this will give us each of the row numbers. That's not useful. So now here's what we're going to do. All, and we're going to do ch for ch in row. So basically, ch equals dot. So basically, we're going to loop over every character in the row and say whether it equals. Basically, we'll get a list in this case, or a generator returning a bunch of true false values for if the character is a dot. If all of those are true, then we're going to store r here. Get rid of that. Sweet. Okay, we can do the same thing to get empty columns. Empty calls equals, and we'll do c for c comma call in enumerate. I'm going to come back to what that is in a second. We can do if all ch equals dot for ch in call. So the only trick here is we need to figure out how do we get a list of the columns and not the rows. And the trick here is we're just going to do zip star grid like that. And the way this works is, so zip is going to take some number of lists, say n lists, and it's going to give you first the first item of each list grouped together, then the second item of each list grouped together. So in this case, if the lists are all these rows, we're going to take the first item of each row, which will be this dot, this pound, this dot, basically the first column. The next item will be the next column. And so this will give us basically the columns of the grid, which we can then loop over. And so same logic, we can do that. We can test this here. Empty calls, empty rows. Run this again. So the empty columns are 2, 5, and 8. So 0, 1, 2 looks good. 3, 4, 5 looks good. 6, 7, 8 looks good. And then rows will be easier to figure out, but 3 and 7. 0, 1, 2, 3 looks good. 4, 5, 6, 7 looks good. So I think we got it. I think we're happy with that. Now we need to loop over each pair of galaxies and figure out the distance. So we'll do 4 G1 G2 in I guess I think this is, I'm pretty sure, let's see, from iter tools, import, I'm pretty sure combinations is what we want here. Always a little sketchy on these, but I'm pretty sure that's right. Combinations of galaxies, and we give it a 2 to say we want 2. And so now all we need to do is, in fact, we can, wow, we're going to watch this. We're going to do this as a one-liner, equals, and we're going to do sum, like this, of get dist G1, G2, like this. So we haven't defined get dist yet, so obviously we're not quite done. But we're going to loop over each combination of galaxies, and we're going to calculate the distance between them. We're going to sum it up, and that's going to be part 1. So we just have, all we have left is to calculate this function. So we need def get dist G1, G2. And so what we want to do is we want to count the spaces. We need to go the rows. We will walk the rows and we'll walk the columns. And because we have this kind of multiplication factor, we're just going to kind of really brute force this. So we're going to say dist equals 0 for r in range. And so we'll get the min G1 of 0, because that's the rows, G2 of 0. So from the low one there to the high one. So that's going to be max G1 of 0, of 0, G2 of 0. Like that. I think we're going to need to add 1. So with that, and we'll say dist plus equals 2 if r in empty rows, else 1. I think we can do it like that. And then we can do for c in range. Exactly the same here. I'm just going to copy this, and we're just going to change the zeros to 1s because we're working off the second coordinate now. Probably a prettier way to write this, but it'll work, I think. We can do dist plus equals 2 if c in empty calls, else 1. Return dist. And we can test this. Let's see. If I do a Python -I, we can do get dist. Let's look at the example here. So the example, we'll have one that's at 0, 1, 2. So that'd be 2, 0, and one that's at 0, 0, 1, 2, 3. And that comes back at 8. Let's see, 1, 2, 3, 4, 5. Well, that's not correct. Let's see. We're going to run this now. I'm going to hit F5 here. I set up my debugger. I have another video. I'll try to put a link here. So let's see. We're going to go from R equals 0. Okay, that's right. So let's see. What is this like here going to give us? Oh, well, for one, we don't need to count the starting spot. Maybe that's part of the problem is we're here. We want to count the rows. Okay, this is interesting. So right now, we started here with row equals 0. That's nothing. We don't need to add that. We will add 1. We don't need to count. We count this. I guess we can count this row, not. We don't need this +1 for sure. I think that's probably my problem right there. Run this again, see if we. let's just see what the answer looks like. Whoa, didn't expect, oh, because we did, okay. Let's come back here. 6, so we're getting closer. So we're 1, 2, 3, 4, 5, 6. Okay, I think that's right, actually. Let's try another one. Let's try this 3 to 5. So we're going from row 2, 0 to, this was row 4. 0, 1, 2, 3, 4, 5, 6. We get 11. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think we might have it. I guess we could also just, instead of checking it manually, we could also just check our input and see if the answer is actually supposed to be 374. It is. Okay, we're feeling good about this. And input takes a half a second to run, but let's try it. Sweet. Part 2. Pause this while I read it. All right. I think because of how we did this, I'm feeling really good about our decision not to like try to update the grid. Basically, instead of 2, we just need to replace it with 1,000,000. And I think this should be I don't think this should change time at all. So what we're going to do is we're going to say space dist equals 2. And we're going to come down here and put space dist like that. So our part 1 should still run exactly the same. Okay. And then here, put that in there so I have it. Part 2 is going to be the same thing, except we are going to pass in that. And we get a number. That might be my fastest part 2 solve in a long time. So because we didn't try to modify the graph, but because we just used this this function to calculate, just calculate based where the empty rows were, this was really easy. So I'm going to call it here. Thanks for hanging out with me today. I will talk to you tomorrow. Bye.